For 21 years, Listen has provided state-of-the-art audio test solutions for leading audio and electronics companies. Listen continues the tradition of growth and innovation and proudly announces the release of SoundCheck 15, a new version of our flagship audio testing software. This video will provide a guided tour of the new features in SoundCheck 15, including more powerful control with TCP/IP control, a new multimeter, improved plot legend layout, support for accelerometer calibration and force measurement, additional control of Bluetooth interfaces, improved audio mixer, faster setup with automatically selected status.dat files, and enhancements to auto mode in the hardware editor. You can tour the new features in entirety or queue to the features you are most interested in. Section times are indicated in parentheses. External control of SoundCheck is now simpler and more powerful with the new TCP/IP control. This offers significant advantages over ActiveX. SoundCheck has the ability to connect to any programming language on any operating system, either locally or through a network. This means you can now control SoundCheck from a Mac, iPhone, Android phone, etc. TCP/IP also features a more powerful and expandable command format for interacting with SoundCheck. This is extremely valuable to anyone who needs to control SoundCheck from an external program, for example, as part of an overall test plan or factory automation. One computer can control multiple SoundCheck systems, simplifying production line measurements. Setup is configured via the Advanced tab of SoundCheck's Preferences. Enable the TCP/IP server. This is off by default. SoundCheck defaults to port 4444, but this can be changed as long as the assigned port is not in use. These changes will automatically update the SoundCheck 15 ini file. I'll demonstrate a simple example of running a sequence locally using Telnet. TCP/IP control uses text commands and responds in a textual JSON data format. Similar to XML, the JSON format can easily be parsed by any programming language. Via command prompt, enter telnet localhost 4444. To control SoundCheck in a network, replace localhost with the target computer's IP address. Enter the command sequence.run and note the loaded SoundCheck sequence runs in the background, and Telnet also returns a JSON formatted response. I won't cover it here, but the complete command list and return format are found in the SoundCheck 15 manual. Telnet controls SoundCheck by text commands and does not require compiling. We include two examples of using an executable to externally control SoundCheck 15, a C# example and a LabVIEW example. These are found in the External Control Examples folder, and we include both the source code and the exe. These examples provide a logical progression of what's possible with external control in SoundCheck. Let's look at the C# example. SoundCheck is already running, so I don't have to relaunch, but I'll select a sequence and open. Note when I do, the sequence steps appear in the UI. I'll enter a lot and serial number and run the sequence. Since C# has parsed SoundCheck's response, a list of curves will populate this drop list. I can select a curve to display, for example. Let's look at a LabVIEW example. This is a more low-level example, perhaps for engineers who want access to all of SoundCheck's commands. Commands appear on the left and can be executed. I can get status, or I can run a sequence. And note that this is the same sequence run command from our Telnet example. I can get all the memory list data, which returns all my memory list curves, values, results, and waveforms. Some commands require a string. For example, I can get curve and enter the string for the frequency response. The curve and graph appear. These are very simple examples, but you can see having access to all the commands opens endless possibilities with external TCP/IP control. As newer versions of SoundCheck become available with greater capabilities, the command list can easily be expanded. The multimeter has been completely redesigned and offers additional functionality and ease of use. There are now two views, a collapsed meter view or an expanded settings view. Meter view frees up valuable screen real estate while still displaying the important details of the multimeter, including input level, units, averaging, weighting, and bandwidth. In meter view, a clear, simple meter is displayed. The meter changes color to warn of overload or near overload. The meter displays a clear numerical readout with choice of linear or log values. The input signal path also appears in the title bar. Settings view has 4 tabs: measurement, averaging, filters, and limit settings. I'll focus on the new additions to the measurement and filters tabs. Settings made in these tabs are saved in meter view. You can also save and load a meter's settings, set as default, and or save in compact view so the meter reopens in compact meter view. The multimeter now has the ability to measure DC in addition to AC voltage. This enables SoundCheck to be used with DC coupled interfaces like the NI4461 for making DC audio electronic measurements. The meter can be displayed in linear or log values and includes a user-definable dB reference. For example, I can change my current reference from dBV to dBu. Autoscale will auto-adjust the meter to the range of input, and the dB window scale can be adjusted. In the Filters tab, the high and low pass filters can be useful for removing electrical noise in electronic measurements or low frequency background noise in acoustic measurements. The display resolution is now accessed by right-clicking the meter. For example, I can reset my meter to 2 decimals of precision. You can also right-click to copy the meter to your dB reference. New plot legend options have been added in SoundCheck 15. Dragging a curve now auto-sizes the legend. Right-click to disable the auto-size option and the legend can be adjusted to your preference. Scrolling through the collapsed plot legend has also been improved in SoundCheck 15. You can now toggle the plot legend to be visible or invisible, giving you more area for the graph. Now you have the ability to place the legend at either the top or right of the graph. And if the names are too long, you can adjust to display more graph area. If auto-sizing is disabled, placing the cursor over a curve or waveform will display the entire name. Right-click the graph and choose Preferences, and the legend settings, auto-size, visibility, and position can be saved as a preference. The polar plot legend has also been improved. Not only is it visually more appealing than previous versions, it also takes full advantage of the legend area. Similar to the XY graph, the legend will auto-size for data selected in a polar plot. Large amounts of data are elegantly handled even as the graph is resized. SoundCheck now supports accelerometer and other vibration transducer calibration and related force units, including meters per second squared, newtons, and Gs. This enables measurement of linear motors like those used in haptic devices. Calibration is similar to a microphone calibration, except units are reflected in force units. I'll demonstrate. First, I'll create an accelerometer signal path. I'll set the input and choose the accelerometer calibration file, and you can see the default sensitivity is reflected in millivolts per meters per second squared. SoundCheck 15 also contains an accelerometer calibration sequence. I'll select the sequence and calibrate device. I'm using a B&K 4294 calibrator and a 4519003 accelerometer. When completed, sensitivity is now reflected in force units, and you can be assured of accurate force measurements with your accelerometer. If you're interested in force measurement, Listen has a linear motor test sequence available for download from our website. Check it out. SoundCheck has direct support of the Portland Tool and Die BTC 4148 and BQC 4148 Bluetooth interfaces for several versions now. Message steps allow you to control the BTC or BQC from your sequence. SoundCheck 15 continues to improve on integration with these interfaces. You can now control inquiry time, making response and pairing times much faster. Inquiry can also be adjusted directly from the step and rescanned. For even faster Bluetooth pairing, the Bluetooth address can be directly entered into the step or entered via a barcode scanner, for example. Imagine the time these additions can save testing Bluetooth devices on the production line. You can now show or clear the list of paired Bluetooth devices. For example, on the BTC disconnect step, a step that unlinks the Bluetooth device under test, the step can be configured to automatically clear the list of paired Bluetooth devices. And now, SoundCheck has the ability to detect when a Bluetooth connection has failed. And this is useful for determining logic in your sequence. For example, if the Bluetooth step has failed, whether to rerun the step. The Audio Mixer Custom VI has been updated to support the latest Windows and Mac operating systems. The VI is included in the list of custom VIs from the Step Template library. This allows control of any audio input or output via steps in SoundCheck. For example, USB headset volume can be adjusted for testing via this custom step. Steps could be added to your sequence to force unity gain for consistent calibration. This is a particularly useful step on computers where the audio hardware might be used with other audio applications. Setup is now faster with automatically selected status.dat files. If the status.dat path is pointed to a folder containing multiple SoundCheck status.dat files, the software will automatically load the file that corresponds to the currently plugged-in hardware key. A single computer image can be created with SoundCheck pre-configured rather than having to set up each individual key on the corresponding computer. Currently, SoundCheck is running in demo mode with the USB key removed. I'll attach the key and open the SoundCheck preferences and folder paths. I'll steer SoundCheck to a folder containing a bunch of status.dat files and choose Current Folder. SoundCheck automatically links the correct status.dat file to the attached key. This can be a big time saver for customers who are setting up multiple SoundCheck computers. Features like this are a direct result of customer feedback, which we welcome and encourage. From SoundCheck's help menu, we make it easy to request support, request a feature, or even report a bug. Auto mode was introduced to the hardware editor in SoundCheck 14. It allows SoundCheck to detect and maintain any listened audio interface, so most users will never have to open the hardware editor or modify hardware settings. Input and output VP values are stored in the firmware of listen interfaces and automatically recalled when auto mode is selected. Now in SoundCheck 15, if auto mode is enabled, the audio table is automatically refreshed as hardware is plugged and unplugged without the need to reopen the hardware editor to see changes updated. This makes system setup faster and simpler. Thank you for watching. SoundCheck 15 is free to users with an active support and maintenance contract. Please contact sales if you have additional questions or are interested in upgrading to the newest version. If you would like more info about SoundCheck, please visit our website, listening.com, for a more comprehensive overview. Our site has additional webinars, tech notes, and sequences for download.